Hi, my name is Andy Ravenna, and I'm a technical trainer at SAS Institute. What I'd like to show you today is a hands-on workshop and give you an introduction into SAS Visual Statistics on SAS Viya. So at a very high level, I'm just going to give you a nice quick introduction, and then I'm going to get right into my demonstration. Let's go ahead and get started. So what I'd like to talk to you just a little bit about is what SAS Viya is and how SAS Visual Statistics fits into SAS Viya. I also am going to cover some regression basics at a very high level. Hopefully you're already familiar with regression. That's probably why you're watching this video. If you're not, it's pretty easy to follow along. And then I'm going to do a demonstration where I'm actually going to perform a logistic regression for you. What exactly is SAS Viya? Well, SAS Viya is the latest piece of software that you can get from SAS. It has some really great features available in it, and one of the features that I want to focus in on, which is really most important to you and I, is the concept that SAS Viya is going to allow you to take big data, bump it up into memory, and then not only put the data in memory, but also perform the analytics in memory. This works really well for us, especially when we have algorithms that are very computationally expensive. And so that's one of the reasons I think SAS Viya is most important to us. What is SAS Visual Statistics? Well, SAS Visual Statistics is a web-based product that is an add-on to SAS Visual Analytics. I think in a very general way, a typical session for you might be, you might log into SAS Visual Analytics and you would actually explore your data and clean up your data. And then you would use SAS Visual Statistics to start to perform some unsupervised and supervised analysis. I want to talk to you just a little bit about regression. Regression has been around for a really long time, and we like to use regression for a couple of important reasons. One of the main reasons we like to use regression is because it'll allow us to come up with a prediction formula that's going to allow us to predict new cases. So we're going to take data from the past, and then we're going to use that data to help us build a model. That model is really just going to be some sort of prediction formula. And then we can use that prediction formula on new data, for example, new customers, new patients, and we can make predictions about them. Another feature that we can take advantage of when we're performing a regression is it can help us narrow down the information that we want to plug into a model. Some of you out there might have a lot of information about what it is that you're trying to understand. For example, maybe you have a lot of information about your patients or your customers. Maybe you even have like 50 columns or 50 inputs. Well, typically, one of the things that we found is that it's not very helpful to our model to have many, many inputs. A more complex model is just more difficult to maintain and more difficult to execute. So what we want to do is narrow down that list of inputs to only those that are most important. And that's the process of sequential selection. Some of you might even be familiar with some of these selection methods. For example, the forward selection method, where you start with an empty model and then you add inputs one at a time and keep the ones that are most important. We're actually not going to be performing a typical regression where we would be making a prediction on a continuous target. For example, maybe we're trying to predict how much a customer was going to spend. What we're going to focus in on is in a binary logistic regression. And I have an example here where we're asking ourselves the question, hey, can we use both credit score and home ownership to help us make a prediction about whether somebody is going to default on a loan or not? So what we're trying to do in this case is we're trying to make a prediction about a categorical variable. And so the values for whether a customer defaults on a loan or not are yes or no. So we want to know, looking at information about our customers, do we predict they will default on a loan or they will not default on a loan? This is very similar to the binary logistic regression I'm going to show you in the demonstration, but we're going to be making a prediction about something slightly different. All right, let's get right into my demonstration. Okay, let's go ahead and get started in the demonstration. Now you'll notice I went ahead and turned off my video, and that way I don't cover up anything in the interface so that you can see all the important features. As you can see, I've already logged into SAS Drive, and now I'm ready to begin my binary logistic regression. So I'm going to go to the upper left-hand corner menu. We call that sometimes the hamburger menu because it's got the 3 lines on it. It looks a little bit like a hamburger. And I'm going to go into Explore and Visualize. And basically, this opens up the SAS Visual Analytics interface. And now Visual Analytics is going to ask me, hey, Andy, what do you want to do? Do you want to start up with a brand new report, or do you want to start up with some data? Well, we're going to start with some data. And I went ahead and loaded our data into memory, so you and I don't have to wait for that. We're going to be using this VS Bank table. So this is data that has to do with a banking campaign where over a 6-month period, they're gathered information, just over 1 million rows of data about customers who made purchases from the bank about different products, things like loans and credit cards. And so that's the data that you and I are going to be using. And we'll become a little bit more familiar with it as we start to work through our example. One of the things that we're going to see is if I scroll down here in the list of all the measures, I have a measure called target binary new product. This is a binary variable. It's a flag going between 0 and 1 that indicates whether a customer made a purchase during the campaign season. Now, because it's coded as 0s and 1s, the software actually thinks that it's a measure, but we want it to be a category. So what I'm going to do is I'm going to go ahead and edit the properties for our primary target variable, and we're going to change the classification from a measure to a category. And now you'll see what it does is it pops that up into my list of category variables. And we can also see the cardinality here. So there are 2 levels to that variable. One of the nice features about the newest version of SAS Visual Analytics and SAS Visual Statistics is that you can actually turn on an option that says, hey, if you find any binary variables that are measures, go ahead and automatically convert them into categories. But I did not turn that on, so we did it manually. Okay, so now I've got a target variable. I'm going to go ahead and begin to build my logistic regression to help us make predictions about whether a customer is going to make a purchase or not. I'm going to come over to the Objects pane, and I'm going to scroll all the way down almost to the bottom, and we can see our list of SAS Visual Statistics objects. And I'm either going to double-click or drag and drop. I tried double-clicking, it seemed to work. And that's going to place my logistic regression object directly into page number 1. So now we have 1 object on this page in my report. I'm also going to go ahead and take advantage of a very interesting option by coming to this upper right-hand corner menu. This menu has several different options in it, and we're going to select one of these interface options that says that I would like to disable my auto refresh. Basically, what that means is I want to come in to this particular object and make a whole bunch of changes, but I don't want it to refresh for each individual change that I make. I want to wait until I'm done with all of my changes, and then I'll say I'm ready to refresh. So what are we going to do? We're actually going to assign some roles to this particular logistic regression. Now, the response variable or the target variable was that variable that I just showed you. It's that binary flag that indicates whether a customer made a purchase during the campaign season. So we're going to go ahead and select that. Now we want to start to specify our inputs. So what are some of the columns that we're going to use to help us determine whether a customer makes a purchase or not? I actually have a whole bunch of cleaned up continuous variables. I have a log_i RFM1 all the way down to log_i RFM9. So what are these RFM variables? They're recency, frequency, monetary variables. And they're just a really convenient way to group a whole bunch of continuous variables. You can see, for example, that RFM1 is the average sales over the past 3 years, whereas RFM12 is the customer tenure in months. Now, the reason that we have log_i underscore as a preceding indicator to each of those variables is because they've all been cleaned up using a log transformation and imputation for missing values. So we're going to go ahead and include those in our model. And the other thing I want to do is I want to scroll down here to my classification effects, and we're actually going to add in 2 variables here. There are 2 categorical variables available to us that are information about our customer. One is the account activity level, and the other is the customer value level. So we're going to go ahead and add both of those in. Now I'm ready to go ahead and take a look at my logistic regression. So what I'm going to do is I'm going to come up to the overflow menu in the upper right-hand corner, and now under interface options, I'm going to say, hey, let's enable that auto refresh. I'm also going to collapse this data roles pane because that's going to give us just a little bit more real estate as we're examining what happens. Along the top here, you'll notice that we get a name of our model. It's a logistic regression. Here's our target variable. We are modeling an event equals a 1, which is a purchase. We also have a statistic which tells us a little bit about how that model is performing. This is the KS statistic. We can see how many observations were used. I've got a total of 3 panels here, a fit summary panel, a residual plot, and a confusion matrix. I'd like to get even more real estate on each of these, so I'm going to come over to my options, and I'm going to scroll down. And under the model display general options, there's a plot layout that we can change from fit to stack. And what that's going to do is that's going to put each of those pieces of information on a separate tab. So now I've got my fit summary tab, my residual tab, and my assessment. So we added a total of 12 plus 2, 14 inputs into this logistic regression. And as I scroll up and down, you'll see the most important variables to this analysis are at the top, and they are these long purple lines. And what's being plotted here is the p-value, but it's not just the p-value, it's actually the minus log of the p-value. So let's think about this. Inputs that are very significant are going to have a very small p-value. If you take the log of a very small value, you get a very large value, but it's going to be negative. So that's why we're doing a negative of that value. So in other words, a very small p-value is going to give us a very large positive negative log value. And so we can see customer value level is very important. And as we scroll down, we'll notice that we've got this black line here. That black line is put at 0.05%. So anything that is less than 5%, anything that is greater than 5% is not going to be significant. So we can see that we have one variable here, the last product purchase amount, which is not significant at the 5% level. All right, that's our fit summary panel. It helps us see which of these inputs are important and which ones are not. We also have a residual plot. A residual plot for a logistic regression is probably most helpful when we're trying to spot if we have any outliers or unusual observations. And not seeing anything here to worry about, I'm going to move over to the assessment plot. By default, for the assessment plot, we're going to get a confusion matrix. And the confusion matrix, you might remember, has those 4 key statistics. It has the true positives, in other words, those particular purchasers in the past that were identified as purchasers by this model. And then we also have our true negatives, those non-purchasers who were identified as non-purchasers. And then we also have the misclassification numbers as well. If I do a right mouse button click, I can switch over to the lift plot, which gives me an indication of how this model is helpful. Or in other words, what kind of lift do we get from this model? The model is the blue line, and if I mouse over here at the 5th percentile, you can see that the model is giving me about a 3.7 lift. What that means is if I were to go to the top 5th percentile of my customers using this model, I am 3.7 times more likely to reach a purchaser versus just picking customers at random. So that sounds like a pretty nice lift. I'm going to do another right mouse button click, and I'm going to select the ROC chart, or the receiver operator characteristic chart. This is a chart that allows me to see how well my model is avoiding misclassifications. So this has the sensitivity posted against 1 minus the specificity. So we have 1 minus the specificity down here as my x-axis and the sensitivity on my y-axis. The blue curve is my model. If my model were to 100% correctly identify all the purchasers and non-purchasers, in other words, if there were no misclassifications, we would have a very big blue curve. In fact, it would fit the outer outline of that rectangle that I'm drawing right now with my mouse. So in other words, on the ROC chart, what we want is a very full curve. So that's one way to quantify how well my model's performing, is that if we have a very full curve. So one of the things that we can do is we can plot this ROC curve against the ROC curve of another model, and then of course we would identify the model that had the larger ROC curve. Now sometimes when we have multiple plots, it's a little bit difficult to read. So one of the statistics that I really like is this KS statistic. The KS statistic is calculated by finding that vertical line, or vertical distance, between what we think of as my default or base model, which would be just picking customers at random, and my curve. So we want the maximum distance, maximum vertical distance between those two, and we get a separation here of about a 0.55. So that means if we were to compare this KS statistic against another KS statistic, we would want the model that has the higher KS value. All right. I'm now going to move over to the misclassification chart. And the misclassification chart is very, very similar to the very first pane of information that we looked at. You might remember if I do a right mouse button click, I can get back to that confusion matrix. Well, these are the exact same statistics that are in that confusion matrix. So we can see our true negative values as well as my true positive values. And then as well as the misclassification are here. I'm going to go to the upper right-hand corner of my logistic regression and click the maximize button, because one of the questions that I often get when I'm working with students is they really want to know, hey, where are all the numbers? We looked at a lot of charts of information, but where can I see the actual numbers? And the actual numbers are in this detailed table. So for example, maybe you'd actually like to see the parameter estimates for that binary logistic regression that we created. Well, here's the y-intercept, and here are the parameter estimates for our categorical variables and all of our continuous variables. We can also see all of the model fit statistics that have been created that you might want to use to help you evaluate this model. So we have the -2 log likelihood, the Akiyike's criterion, the Bayesian information criterion. So hopefully you'll find your very favorite statistic here. All right, so those are where all the numbers are. I'm actually going to go ahead and restore that. Then I'm going to come up to the Page tab, and you'll see that we also have a little overflow or options menu in the Page tab. And from here, I can actually duplicate this particular page. So I've just taken that logistic regression and copied it onto a brand new page. And the reason I did that is because I want to make a couple more changes. So first, I'm going to come to our upper right-hand corner overflow menu. And from there, I'm going to go to my interface options. And once again, I'm going to select that I would like to disable the auto refresh. And here are the changes that I'm going to make. First, I'm going to come over to my data pane, and I'm going to create a new data item. That new data item is going to be a partition. So one of the things that we often like to do when we are building new models to help us make predictions is we want to find a model that generalizes well. A model that generalizes well is one that is not only going to perform well on the data that we use to create the model, but it also performs well on the new data that comes down the pipeline. So we want a model that's going to do well in both situations. And a great way to do that is by partitioning the data. We're actually just going to create two partitions where we are going to put 50% into the training and 50% into the validation. I think we want 0.5. No, we want 50%. We're going to go ahead and click on OK. And so now I've created that partition variable and it's available to me. So one of the changes I'm going to make here is I'm going to come over to our roles and I'm going to select the logistic regression object to make it the active item in my interface. And I'm going to scroll down into the roles of the logistic regression, and I'm now going to add in that partition. So here's the new partition. And in just a second, you're going to be able to see how that affects my output. But I'm also want to change one other option here that's available to us. And that is under the logistic regression, I want to use a variable selection method. So let's go ahead and use the fast backward elimination method. Fast backward is basically a method where we start with the full model and then we eliminate those items as they are not significant. The fast backward method actually uses numerical shortcuts over the backward method, so it's a little bit faster, and thus its name. So we don't want to have any terms in the model that are going to be over that 1% significant level. So we only want things that are significant at 1%. I'm now going to come to the upper right-hand corner once again into the overflow, and now I'm ready to enable my auto refresh. Now we see the new logistic regression model that we built, and let me show you a couple of changes that you might notice. First of all, when we look at the fit summary panel, because we chose to use that fast backward elimination method, you can see that 3 terms which were not significant at the 1% level were actually removed from the model. So they are not part of this model. And one of the other things that I want you to notice is that since we now have a partition, if I come over to the assessment panel, we're now going to see information for both the training partition and the validation partition. When we are trying to pick a supervised model that generalizes well, we'll actually use those validation statistics to help us pick the correct model. The other thing I want to show you is that if I open up that details table, because we chose to eliminate methods and use a fast backward method, and we chose to ask the software to eliminate them from the model, we're going to also be able to see the selection summary. So you can see in what order those terms were pulled out of the model. All right, I'm going to go ahead and close that table. And that's it for my demonstration. So let me just pull back to my slides for just a second and cover one more thing. Thanks so much for joining me in this hands-on workshop where you got an opportunity to learn just a little bit about SAS Visual Statistics. If you'd like to learn more, you can see on this slide that we also offer SAS training courses. So for example, you might be interested in SAS Visual Statistics on SAS Viya, interactive model building, where not only would you learn how to do a logistic regression, but we also show you things like linear regression, clusters, and decision trees. Also, if you notice on this slide, there is a huge selection of free SAS tutorials that you can get access to that can help you go ahead and get started and continue to learn about SAS and SAS Viya. And there's also a link to the online documentation. So thanks again for joining me. We'll see you next time.